Welcome back to the... Today we're going to play around with a classic, the Simpson 260. Now this is an older version. I believe it's from the 50s. It's actually made in Canada, so my friends up in Canada, here's some great product from up your way. And, you know, it's a pretty good example. It's seen some things, but it's from the 50s. I do not know if it works, so we're going to get into that. I think to start out with, you can see I experimented. We'll clean up these corroded terminals first, since we have it open. Let's take a look here. Going in. Will it focus? No, it will not focus. There we go. So you can see that's pretty corroded. That one's even more corroded, and so is that one. So to achieve that, what we'll do is we'll take one of these fancy new Milwaukee Dremel-esque type tools with just a small little wire brush on it, and we'll get down in there and just run it a little. So carefully putting it in so that none of the wire brush strands are dragging on anything, and then turn it on low speed, turn it off. Now that didn't quite clean it up completely, so we'll run it just a little bit more. You don't want to do this too much. I do not know what these are made of, so it's a steel wire brush. It's all I had in here, so I don't want to run it too abrasively. Now that's not too bad. I think I'm happy with that. It's pretty shiny. So let's move over here and do the same thing with these. Carefully getting the wire brushes in and turn it on. Let's see, we're getting dust out. And that one still has some corrosion in it. So, but let me go get something quick. Okay, so a neat thing that I got to play around with here is this blower. This is a completely cheap blow the socks off your dog blower here. It is 100% Chinesium. You can tell by the plastic being the way that it is, but it takes an M18 battery. So I thought, well, maybe something to blow some dust off stuff in the shop might be handy. So we're going to give this thing a go. We'll see if we can blow the dust off of this. It's got 4 settings. So let's zoom in here. Alright, we're back. We've zoomed in. Let's see how this dust bluster thing here does. Okay, it actually blew the dust away. So that's good. So we'll just keep cleaning here, short bursts, until we get the corrosion off of our jacks here. It's getting better. I'm actually surprised how well that duster works. Okay, I think that's as much as I want to try and clean that one. It doesn't seem like I'm really gaining anything more on it. Sometimes these things just show some signs of age. They're not going to make them perfect again. Okay, let's do the last one here. I wonder if we could... yeah, I could go for that. So it's cleaner. It's not perfect, but it is cleaner. So let's crack this thing open and see what it looks like inside. We'll blow it out since we have a means of doing so. So there we go. There's our cleaned up terminals. They're not perfect, but that's okay. So the Simpson 260 has 4 screws in the back, and the Simpson 260 is an interesting meter. It was originally designed in the 1930s, this particular variant being from the 50s. We'll see how it looks inside, but I mean, the meter has had subtle changes throughout time. It's not been the same. There's been upgrades, you know, printed circuit boards and types of meters that are in them and everything. So this one's kind of an earlier variant, but it's not super early. Hey, we got a screw out on that one. So all I'm doing here is this extended tip Klein multi screwdriver. It won't reach in if I have it all the way together. So all I'm doing is I'm sticking the screw tip in and just running the screwdriver on top of the hex. Kind of get a little extra out of it. That gets our screw out as well. So let's carefully lift our base off of the meter. Okay, so far everything looks pretty good. I'm going to turn this upside down and not lose all the fasteners. Let's look inside the base. Carefully move that. The base looks nice and clean. Has that classic old semiconductor smell going on in it. If you know, you know. This looks nice. Now it's interesting, this at this time they still had the leather handle, which is kind of neat. It's a neat neat throwback. I think the ones made here in the States had the plastic handle like you probably saw on the Simpson 360 if you watched that other video. So let's get our case out of the way and let's take a look at our meter. Now the meter looks very clean inside. This is a printed circuit board. You can see that by the way that it is. And it says Simpson Series III in it. So this is all true components. Our battery terminals look pretty good actually. So this takes a single D cell up here and 4 double A's. One here, one here, one here. Well, 2 up top and 1 over here. So we'll put some batteries in it and see what we get. But let's just look around here a little bit. All the wiring looks good in it. The meter movement isn't bad. You can see it actually pretty much goes right to 0. I'm moving a little bit, so it's fluttering there. Bunch of resistors on the top here. All the values on them. Switches look good and clean. Yeah, I think this could be... we're missing the fuse. So let me see if I can find out what size fuse this is supposed to be, and we'll put a fuse in it. Okay, so here we go. If you can squint your eyes just right, you will see that a 1 amp fuse, 250 volt rated, is what we need for our meter to work. This may be a surprise, but I happen to have a 1 amp fuse laying around in the shop. It does not say the duration for the fuse, but I happen to have a quick blowing, fast acting fuse. Probably the safest route to go. And it appears as though I may have the wrong size fuse. I may not have a fuse in the shop. Okay, so it's not right, but we did get that fuse to stay in there. It's a 1 amp fuse that's quite fast acting. It's not the correct size. I'll get the correct size on order, but we'll roll with it. I think it should work to just test the meter out. So for anything like this meter that has something that is a slow drain, I like to use these ProCell constant draw batteries. They kind of last a little longer and they're not as likely to grow, if you know what I mean, in the what you've hooked them up in. So I think we'll use these. We'll give them a go. And this here is pretty simple. You have a polarity marked here, plus and minus. So we'll put our D cell in just like this. And then on the sides here, if you look, You have a plus, a minus, a plus, a minus. So we can put all of these in. This one goes like this in there. This one goes in here. And I'm setting it in the sharp pointy bit here first, because I don't think sliding the battery on that's probably very optimum. And then these will go in here. Seems like we have good tension on everything. Let's carefully turn this over and get some leads. So before we put it back together, let's just see if we did indeed get that fuse to work. And get our leads pushed in. And probably the best way is to go to resistance and see we're not getting any signs of life. Should be on the right setting. Let's see if I can do anything with it like this. And this meter could just have issues. This is the game when you get used stuff. It appears as though the resistance, oh yeah, we're not in resistance. I went to microamps. But that should be going to full scale. Ooh, we might have something. We might have something. We had a jump. Okay, so we have signs of life. And what we want to do is do our zero adjust. There we go. So let me play around with this and see if I can get it to reliably work with this wrong fuse in it, and we'll be back. And we're back. So we got the fuse to work. If you don't ask how, it's better off. Important thing is we have the right size fuse in it. We didn't just jumper it out. You don't want to just jumper things like that out. But we got that to work reliably. So what we want to do is figure out what we're going to test. Let's test some voltage. Let's see how it looks with DC. We have our DC power supply here. There we go. It's currently outputting 4 volts. Let's do less than that. Okay. So if we have our power supply leads, I need to get better leads for this power supply, but these will work for now. We have them clipped on there. And we're in our 2.5 volt scale, so we want to go to voltage set, and we want to go way down. We don't want to be at 4, down to, yeah, that'll work. So the lowest we can go is 0.6 volts. So let's see what we get. That is not bad. So we want to be, we're on the 2.5 volt scale. This here is the 250, but you move the decimal and it works. So that's 2.5. Here's 5, 5.5, 6. We are pretty much right on that. Alright, so we're back. I've zoomed in. You can see here that we are right at 0.6. We'll go to voltage set. Tenths. Let's go up to 0.7. 0.8, 0.9, 1 volt. We're pretty darn close. Let's keep going up. 1.1, 1.2, 1.3, 1.4, 1.5, right on. 1.6, 7, 8, 9, 2 volts. That's working pretty good. 2.1, 2.2, 2.3, 2.4, 2.5. We are right at full scale. So let's go to the 10 volt scale. We're pretty close there. So if we get to the 3 volt mark, 2.7, 8, 9, 3 volt. It's pretty good. Let's get up to 4 volts. See where we're at. That is right there on the 4. Let's take it up to 6. Okay, that one's a little low, but it's not bad. Pretty close. Let's keep going up here to 8. 8 volts. It's pretty close. So we may have some resistors that aren't exactly right. Might be why we're seeing what we're seeing. But it's darn close. Let's go up to the 10 volt mark. We are just shy of full scale. So we might have a resistor in here that's not quite doing what it should. If that's the case, we'll probably start to see the others' scales sag as well. Now we're only going to be able to go up to 30 volts. So we're at 10 now. We're on the 50 volt scale, and that 10, that looks right on. That looks really good. So let's go to volt increments. Let's go to 11, 12, 13, 14, 15. Now 15, you can see that looks just a hair shy. You do have a little parallax with the way the camera is, but I'd say we have a resistor that's not right, or a few that aren't quite right. 20 volts is just a little shy still. And 30 volts, also a little shy, so that's probably a resistor that's not acting right. And 36 volts is full scale. That's saying, looks like 35 and a quarter, doesn't it? It doesn't quite look like it's at 35 volts. And that's okay. It's just one of those things that they're old meters. So it's something that I kind of want to get into here is learn how to fix these things. It would be a resistor that's not in good shape. We'll figure out which resistor it is, and maybe we could get this working. So there's our DC voltage test. I can't really do much other than 120 volt AC. I don't have an AC power supply here yet. Working on it, but I'm not there yet. So I think we'll forgo the AC test until we get a little bit better equipment here. But we can play around with resistance a little bit, so let's do that. Okay, so we're back. We got a really cool resistor tester here. I got this thing really cheap, and this dial, the 0 to 9, doesn't seem to be working properly, but our 10, all the other scales seem to work, so we should be good there. So with meters like this, what you want to do is short your leads together, and then you have a 0 adjust here, and you want to adjust your 0 right to the 0 in the scale. Alright, so we got our meter leads jammed in, and this is the 1K zone, I believe. This is the 1K scale. So let's just get that just right. And so right there should be 1K, which is pretty close to our 10. But let's start here with the 100 scale, because that's what we're on. So there's 100 ohms. That's reasonably close. Let's go to 200 ohms. Also reasonably close. 300 ohms. That's starting to be off a little bit. 400 ohms. 500 ohms, 600 ohms. It's not horrible. I mean, you would get the idea of what it is. 900 ohms. Let's take that back. Go up to the 100 scale. Now that seems a little strong, but I didn't check all of these resistors to know. That 2K is pretty close. 3K, 4K, 5K. 6 is that line in between 50 and 70. There's 70. 70 is a little low. 80, 90. 10. It's not bad. Now we should be able to go to our 10K scale. And that should be close to 1, and it is. Let's just come up on that. It's a little high on the 2, 3, 4. I mean, we're within reason. It's not exact, but it's not spectacular either. That one's a little high. I should probably go through this piece of test equipment and see how close the resistors in it are, because all of this stuff is all old and I don't know how accurate any of it is. I may have to rebuild this if we really want to get into exact precise measurements with the meters here. But I mean, we ran through the whole scale here and it's pretty close. The ohm meter is reasonably close on this. It's not horrible, but it could probably be a little bit better. I do have something here that we can try and test the milliamp scale with, so let me get that set up and we'll be back. Okay, so last thing we can play around with here is the milliamp scale. So we have a milliamp tester here hooked up to our meter. Here's our meter leads. And what we should be able to do is we're on 10 milliamps. We should be able to turn this up to about 10 and get full scale. And then I'll have to change ranges to the 100 and we can get up to 20 with this tester. So let's start turning our scale up. I see the needle moving already. That's good. So there is 1 milliamp. And if we look at our scale, we are right at the 1 on our 1 to 10 scale. Here's 10 over here. There's 1 right there. Let's take it up to 2. Right at 2. That is right on. Let's go up to 3. 3's good. 4. 4's not too bad. It's a little low. Let's go up to 5. 5 is also a little on the low side. You can see it now because the camera's in line. Let's go up to 6. 6 is also a little low. So we probably have some resistors in this thing that aren't quite doing what they should be. 8. Little low. 9. Also a little low. And 10. Now I don't know if this meter is exact or not. I've not compared it against another meter, but it looks like that might be close. So let's change our scale to the 100 milliamp scale. So now we should be reading just about at the 1. We're a little bit above 1, but let's just turn this all the way up to 20 and see how close to the 2 we get. There we are, 20 milliamps, and we are pretty close to the 2. So there's 20 milliamps. It's a pretty close test, actually. It's not horrible. I mean, you would be pretty accurate with this If it was super sensitive type stuff, you probably wouldn't be very happy with that. But for a meter from the 1950s, I think that's pretty cool. So I was playing around here, and I noticed that if I go over on these scales and go back down, that current scale is almost right on. So we go down to 9, that is right on. Go down to 8, right on. We go down to 7, right on. 6, right on. 5, very close. 4. Now at that point, 4 is high. So going up, it's accurate going up to 4, and then 4 down, you'll see they are a little high. And I'll run back up through them and show it to you. 2's a little high. 1's a little high. Let's go down to 0. Now on the back going up, 1 is right on. 2 is right on. 3 is right on. 4 is very, very close. There it goes. It's going up. Now we get to 5. Starts getting a little low. 6 is low. 7, low. 8, low. So you get the idea. If you know what that is, let me know in the comments. So when you go down, here we'll go down to 6. Oh, I went down too low. Let's go down to 5. If I go down to 5, it's basically right on. But if I go up to 5, it's a little bit on the low side. And then when we get down to 4, 4 is a little high, but when we go up, 4 is accurate. So that's pretty interesting. That's probably something very, very specific that's wrong with this, and I just don't know what it is. So if you know what it is, let me know in the description, because like I said, I wouldn't mind fixing this meter up and using it in the shop here. Maybe we'll see it in videos and stuff like that. So just thought that was interesting and thought I'd point it out. Alright, we are back. So I thought I did not have a means of testing the AC on this thing, but I do. So we are hooked up to an AC variac that is a 240 volt model. So that boosts the voltage to about 300 volts, and you can see here that we are just about to 300 volts, and we verified with the Fluke 87 here. So let's just dial this thing down a little bit to about 250. And that is not bad. I believe the Simpson 260s probably reading about 260. So it might be off a little bit. Let's take it down till the till the Fluke 87 says 200 and see what we get. Yeah. So the Fluke 87 says 200 and the Simpson 260 is reading just a little high. Alright, let's keep going down. Now mind you, this is the 1000 volt scale. So let me go to the 250 volt scale now that we're below 250. Let's see what we got. So now our resolution's a bit better, but we are still, actually we are right on. If you look right here, you got a little parallax with your view, but we're pretty good there. So let's just start taking this down to 175. 175. We are right on, which is nice. Alright, let's keep going down to 150. This variac is actually pretty decent shape. There we go. We're right at 150. Both of them agree. 125. That time I adjusted it with the Simpson 260 and the Fluke 180, the Fluke 87 agrees. Now I'm only going to look at the Simpson 260 and take it down to 100. Right there. Pretty good. Let's keep going down to 75. Down to 50. Now after 50 we can go to another scale, so this is where you might start seeing it's not bad. So we can go down to the 50 volt scale now. Now we should see better resolution. This should be 45. I'm not going to get a whole lot of movement, so I'm going to set this at 40. Might be a little touchy. It's pretty good. Let's go down to 20. If we can. Pretty close. Now once we get below 10, we can go to another scale still. So we're right around 9. So let's go down to the 10 volt scale. And that is indeed right at 9. Let's go down to 5. This might be hard to get right. Pretty close. Pretty close. So that actually does show a little low. Right there is 5. Yeah, pretty close. See if I can get 2.5. It's going to be hard. We'll go for 3. Let's go for 3. Yeah, we'll try for 2.5. Why not? Now the variac drops out. Can't go that low. So, alright, well that's okay. But we know that we can indeed measure AC voltage with this thing. So that's a plus. Alright, so I hope this was interesting. You can see we got to test the DC voltage, we got to test the resistance, and we got to test the milliamp range. This one was in pretty good shape. We probably have some resistors that aren't quite in the best of condition in the meter, but I probably should prove out my test rigs with the old Fluke 87 or something like that. Honestly, I just hooked this stuff up and turned it to the values and took it at name face that it was what it says it was. So we probably could test our tester equipment and figure out a little bit better stuff there. But I think we're doing pretty good with what we got. The meter's close, and considering it's from the 1950s, and it's probably not seen any major amount of servicing in that time, it's pretty darn accurate. So it just goes to show these old rigs still kind of hold their own even after all this time, and you know, they're worthy of having some life yet. So we got some good slow draw batteries in it. They should last a long time in there and not grow and become acid mess, and we got a good meter to play around with. So we're going to continue with this. If there are resistors that are goofed up, I would actually like to get into repairing these things and making them as accurate as possible. So we might see some of that on the channel, and we'll just keep going with it, and where it goes is where it goes. So as always, thanks for watching and have a great day.